Previously, when we were deriving the gradient of input weights, if you remember, we used loss function j, and then we derived its gradient dw. So for that we needed dh by dz, which is actually the derivative of activation function. So how do we do that? Let's solve that. So we have sigmoid of z. We are using this as activation function. So derivative of sigma becomes derivative with respect to z 1 over 1 plus e minus z, right? Now there are two methods to solve this derivative. One is we directly apply quotient rule to this, and then derivative of first multiplied by this, then negative derivative of the denominator multiplied with the first one. That is easy but a little complicated. So let's follow the second method, which is much more easy. So what I will do is I will transform this function and write it like this, right? We have this function. So if I move it to the numerator, this will become minus 1. So the next step is to apply derivative to this. So this will become minus 1. We know this minus 1 will appear here. After that we have e minus z. This will stay as it is, but with subtraction of minus 1. After that we will take the derivative of the function inside this. So this will be 0 plus derivative of exponentials stay as it is, then multiplied with the derivative of power. So this is derivative of power is minus z. So when we derivate it with respect to dz, this will be minus 1, right? So this can be simplified as minus 1 times 1 plus e power minus z power 2, right? And this is minus e power minus z. So this negative and this negative when multiplied will become e power minus z divided by 1 plus e power minus z. Now it will become plus 2 because I moved it to denominator. Let me rewrite it again here. Derivative of sigma e power minus z divided by 1 plus e power minus z square. Now I want it to be written in this format, right, in this form. So what I can do is I can write it as 1 divided by 1 plus e power minus z, right? And then I can have minus z e power minus z 1 plus e power minus z, right? So if we multiply this, we will get back to this equation. Next step is to use LCM method and split this term. So we can write it like this: 1 plus e power minus z, right? This becomes 1 minus 1 divided by e power minus z. So just to check our LCM, so when we multiply this term with the 1, this will be 1 plus, just this is a check, okay, 1 plus e minus z, right, when multiplied with 1, and then minus 1. So when this one will be multiplied with this will stay as it is, and this one will cancel out with this. So in numerator we will have e power minus z, and in denominator we will have e power 1 plus e power minus z. Okay, so we have solved this. So now we know this is equal to h, or sigma z. We can see it from the given function. So this becomes sigma z, then inside the bracket we have 1, and once again this is sigma of z. So the derivative of activation function is derived here. We can also write it like this: sigma of z is equal to h 1 minus h. So this is the derivative of sigmoid function which we are using for activation in the neural networks.